Hello, can we see? Are we active now? Can we see the board? Queen, can you see the board? Okay. All right, let's start then. All right. Dimension analysis. Now, what you need to know is that when we talk about dimension, we have to talk about quantity and unit themselves. So we don't need to spend much time on that, but that's something we are familiar with. Now, I know physical quantity, also like force, velocity, acceleration, etc. Now, and we know their units. Now, for dimension, we use dimension to show the relationship between a physical quantity and some fundamental quantities. And what are those fundamental quantities? Mass, length, and what? These are the only three fundamental. No, we have about 7 or 8 fundamental quantities. These are the only three fundamental quantities that we use that we relate to other physical quantities in terms of dimension. Like what dimension does is that it shows the relationship of physical quantities like force, relationship between force and all these three fundamental quantities. So dimension shows the relationship. So that's just the definition in a nutshell. So now let's start with some basic concepts. And for you, when we are talking of dimension, if you don't know the unit of a quantity, you cannot derive the dimension. For instance, first, or if you don't know the formula, if I were asked to find if I was asked to find the dimension of force, if I don't know that force equals to mass times acceleration, which is same thing as what? kg meter per second squared. I can't know that the dimension is what? MLT minus 2. No, M for mass, L for length, which is this meter. This is for the mass, and this second is for the big T. So that's that for that. That's no. You guys will not ask you something like this. Now let's start from the verification of the equation of motion. So you can use dimension to verify some physics equations if they are valid or not. Whenever I use dimension to verify some physics equation and they are not valid, and both sides are not equal, that means the equation is not valid. For instance, if I'm adding quantity A to quantity B and I'm deducing that they are equal to quantity C, it means that both A and B have the same dimension and they also have the same dimension as C. Because if they don't have the same dimension, I can't add them. I cannot add force with acceleration. I can only add the same quantity together. So for me to add the same quantity together, that means they have the same dimension. Same thing applies to negative to subtraction. Are we together? I can't subtract velocity from time. I can only subtract velocity from velocity. Which means for subtraction to be valid in physics, that means what you are subtracting from each other, they have the same dimension. And what they are equal to also have the same dimension. If I subtract velocity from velocity, will I get acceleration? My answer will still be velocity. So whatever they are equals to must also have the same dimension as them. I hope that's clear. Now, I think I wanted to say something. Now, if I say 2a minus 2b equals to what? Where a and b are in meters. Find the dimension of 2a and 2b. What's the answer? If a and b are in meter, what's the answer to this guy? Okay, let's say 2a and 2a minus 2a, where a is in meters. That's 0. What's the dimension?
Meter.
Dimension. The dimension is L. It's not 0. Actually, this is 2a minus 2a. Since a is in meter, that means that's 2 meter minus 2 meter, which gives us 0 meter. Are we together? What's the dimension for 0? 1. What's the dimension for meter? So it's still what? Are we together? So that all number including 0, they have dimension of 1. So whether dimension is less concerned with your coefficient, once you are doing basic arithmetic, the dimension is still equal to the individual dimension. It's less concerned with coefficient. Once you are doing basic arithmetic, not just basic arithmetic, basic arithmetic that involve addition and subtraction alone, not division and multiplication. Are we together? Now, if at square plus bc equals to z, where z is in meter, where z is in meters, find the dimension of b, dimension of a, b, and what, and c. Let's try it. That's class of. Let's try it. If 80 squared plus b equals to z, where z is in meter, find the dimension of a, b, c, and come.
Those are nice. Eight square together. And we don't know the dimension of t.
Should be time now.
Okay, so we are not assuming. So we are not assuming. That means A should be LT. Okay. How will you get by yes?
Let him come on.
Now, okay, let's put it like this. There's no way you can even solve this. No, it is not here. There was the deal which is technically so. There's one question on all these dimensions that I want to do in one time. Still do it. It gives better works.
Are we done? What was the answer?
A should be LT
A is what?
LT minus 2.
LT minus 2. What of B? B is what?
You cannot find it. You don't know what C is. No, BC is L.
Okay, B is L and C is L is grammar.
Okay, no, it's not possible. BC is there must be L.
So BC equals to L. That means B equals to LC minus 1 and C equals to LB minus 1. You can live with this way since you don't know what B and C is. So either of the two. Like this for C and this. Do we get what I did? Huh? So that's
You need B and C subject to the formula.
yeah, that's very good. Now can we move
What? There's a particular question I have.
dimension?
Yes.
Sharp. Can I clean the board? I hope all these guys that have not slept. Una don go. Let me clean. Oh yeah, call the question.
Okay. Given that a quantity S which represents
S.
S is equal to
Which S?
S capital S
Uh-huh.
is equal to A into bracket
Given that the quantity S
is which represents speed. Speed
yeah.
is equal to A into bracket 1 minus E raised power minus BXT
1 minus E raised power
minus E no the E
minus
raised power
B.
minus BXT. Yes. and x is displacement. Find the dimension of the reciprocal of b.
Find the dimension of the reciprocal of b, that is 1 over b. Read the question again. Speed equals to a, abi?
Yes. Into
1 minus e raised by minus b x t. Now, and x is displacement. It's not even hard. Now, for dimension, you cannot have a quantity raised to the power of quantity. The power must have a dimension of 1. Do we get? Any power you have on top of quantity must have a dimension of 1. Am I communicating? So which means all this power must be equals to what? 1. So minus bxt equals to what? Are we together?
Yes.
So that means minus b equals to what? 1 over what? xt. That means b equals to minus 1 over what? Dimension has nothing to do with minus. Are we together?
Yes.
So 1 over b equals to what? Xt, which is what? Is that in the option?
Yes.
That's the correct answer. Do we understand? Ah.
The power.
The power of a quantity always have dimension of 1. The power of a quantity, the dimension must be 1. It is power is always dimensionless. And dimensionless means dimension equals to 1. So minus bxt equals to what? 1. Are we together? So minus b equals to what? 1 over what? Xt. Right?
Yes.
That means b will give us what? Minus what? 1 over xt. Abi? That means, and we have to find the reciprocal of b, which is 1 over b. So 1 over b will give us minus xt, isn't it? Are we together?
Yes.
Dimension has nothing to do with negative sign. What's dimension for x? Whether x or minus x, dimension is still L. Are we together? What's t? So that's the answer. I hope that's clear.
The second question is also C.
Yeah. Okay, let's move on. They are following. Second question.
Okay.
Do you understand this one we just did? Second question.
Okay. The position of a particle at time t is given by x of t.
The position
Of a given particle is given. The position of a particle at time t is given by x of t is equal to a over b all into 1 minus c raised to minus bt.
Abi?
Yes.
Find what?
Where a is the constant, find the dimensions of a and b respectively.
And A is a constant. So we have to find the dimension of that constant, Abi.
And b respectively.
Sharp. It's not sharp, but sharp actually.
And he said a is like the greater than, they wrote it twice.
A far greater than
0.
Okay, like A is far greater than 0. Are we together? We have that A is constant and we should find the direction for A and B.
That means
This means A, whenever I see double sign like this, far greater than, or this is far less than. So here we have x of t, this position, means the left hand side is L, right? So here we have L equals to, let's open the bracket. A over B minus what? A over B C minus what? BT, Abi?
yes.
A over B equals what? L, am I right? So the dimension for, that's find dimension for A and B. Okay. So A now, A will give us what? LB, are we together? If we cross multiply, A will give us LB and B will give us what? Make B the side of the formula. What do you get? A over L. But we need to find B since we have power here. Minus BT equals to 1. Do we remember?
Yes.
So here we have minus B equals to what? 1 over T. B equals to minus 1 over T equals to what? 1 over big T. Dimension has nothing to do with minus. So our B is 1 over big T. Are we together?
Yes.
So that means our A here equals to what? L times 1 over T, and that's what? L per T.
Yes.
Is there? Should be there.
Okay, the first option is LT and party.
Let's finish it first. So that's our A. For our B, B equals to L per T over L, abi?
Yes.
So A and our A is L per T.
The answer is none of the above.
T minus 1. The answer is none of the above. But this is the correct answer. Do we understand?
Sorry. How is A a constant and still have a dimension?
Constant does not mean dimensionless. So acceleration due to gravity, is it constant or not? Does it have dimension?
Yes.
We get constant is different from number. No, number is also a constant. When they say constant, they don't mean there is dimensionless. Do we get? So you can have constant and yet not dimensionless. For which constant do we also have then? Mention constant plenty now. No, this guy is not actually constant. It varies with altitude. Though it doesn't exceed 9.8 and 10. Like Planck constant is a constant, yet it has those seconds in units of which you can get the dimension. Do you understand? So when they say constant, even me then, when I heard constant, I feel like dimensionless, but that's it's only dimensionless if the constant is a number. A quantity can be a constant. Take note of that.
Why did you X? X is bracket. Why not LT?
Where?
The question. And you said X.
No. They are saying the displacement depends on time. It's not that you are multiplying. It's a function of time. That is, if you have your T, you can just substitute T here. I can write my displacement to depends on something else that is not time. Writing it like this, that it depends on time. Do we get? It's not maybe you will multiply it like that. I can just write it as X, but putting something like this, that it depends on time. Whereby if you are given the value of time, you can get your X by substituting time. If it doesn't depend on time, if you have time, you can't substitute it. Do you get? So it depends on time, such that if you have your time, you just substitute it here. Just. Is there more question there? Did I give you guys one question?
Yes.
Yeah. The period of vibration of a liquid. The period of vibration of a liquid. The period of vibration of a liquid depends. The period of vibration of a liquid depends on its density P. It's not like P or like rho. Is it rho or n, whatever? It just looks like P. The period of vibration of a liquid depends on its density P, radius R, and surface tension T. It's not like T. That sign for torque. Use it. It's not torque, but I'm using the symbol of torque. The period of vibration of a liquid depends on its density P, radius R, and surface tension T. Deduce an expression. Yeah. T. Full stop. Deduce an expression for the period of vibration using dimension analysis. Deduce an expression for the period of vibration using dimensional analysis. Deduce an expression for the period of vibration using dimensional analysis. Do we get the question? The period of vibration of a liquid depends on its surface tension T, density P, and radius R. Whether we mention density first, no problem. Deduce an expression for the period of vibration using dimensional analysis. Are we together? Whenever I see the word depends under dimension, it means directly proportional. No.
But I didn't know surface tension.
And I will solve it now. No. Normally on a normal sense, if something is inversely proportional, they also depend on each other. But if one decrease, they depend. So whether inverse, but in dimension, whenever I see the word depend, it's only meant for directly proportional. So the period of vibration, no, period is also time. Depends on what? Density, also depends on radius, also depends on what? Surface tension. So T depends on what? Density R and what? Are we together? Do we get that? So yeah, we can say T equals to what? K P R T. Is that clear? Anything we want to do, we are not touching K. K will just stay there till we end there because it's constant. So yeah. Now label all these PRJ. So T aside, I don't want it to disturb me. T equals to what? P raised power A, R raised power B, J raised power what? C. If there is more, we continue. D, E, F. If there are more. Are we together? So here now we have T equals to what's P density? What's dimension for density? ML minus 3. No mass over volume. So here we have ML minus 3 raised power A, L raised power B, torque in surface tension rather. That's force per unit length. Force is mass times acceleration. Force per unit length and force is mass times acceleration. Acceleration L. That's mt minus 2. So torque is mt minus 2 raised power what? C. So here we have T equals to what? M raised power A, L raised power minus 3A. Are we together? We open the bracket. L raised power B, M raised power C, T raised power minus 2C. Right? I have M, L, and T here, but I only have T here. So I want to write this side to have M and L. M raised power 0, L raised power 0, T raised power 1 equals to what? M raised power A, L raised power minus 3A, M raised power C, T raised power minus 2C. Are we together? No, these two are just one. I'm not changing anything. So I want to compare both sides. So on this side, M raised power 0 on this side equals to what? M raised power A multiplied by what? M raised power C. So we have M raised power 0 equals to what? M raised power A plus C, have we? Using indices. So here we have 0 equals to what? So A equals what? Minus C. Are we together? Now for L raised power 0 equals to what? L raised power minus 3A, have we? 0 equals to minus 3A. Something is missing. Okay, we still have B, sorry. Minus 3A. Oh, there's L raised power B here. Have we? So we have L raised power minus 3 and what? L raised power B, have we? So here we have L raised power 0 equals to L raised power minus 3A plus what? B. So we have 0 equals to minus 3A plus B, have we? So we have 3a equals what? B. So a equals what? B over 3. Are we together? Now, the last one. T raised power 1 equals to what? T raised power minus 2c, abi? So 1 equals to minus 2c. So c equals to what? Minus 1 over 2. So here now we have c is minus 1 over 2. That means a is 1 over 2. Sorry. If a equals to minus c, that means c equals to minus a, abi?
Yes.
Okay, there is no need, sir. A equals to minus what c? So a equals to 1 over 2, abi? It is b that we need to make the second formula here. We've gotten a and c now, abi? C minus half, a half. Now b equals to 3a. Are we together? So you don't need to make a distinction formula here. So b equals to 3a, 1 over 2, which is what? 3 over 2, right? So now, the period of vibration t, don't forget, equals what? K raised power a, rb, torque raised power, which is what? K, what's a? 1 over 2. R, what's b? Minus 1 over 2. Torque, what's c? What is common to all the power? Yeah, B, okay, sorry. B is 3 over 2. C is minus 1 over 2. What's common to the power? 1 over 2, abi? So here you have R3 minus 1, isn't it? You get this back, you get this back, you get this back. Are we together? So here you have T equals what? K. This becomes root, abi? Density R cube minus 1. So here you have T equals what? K root density R cube over what? That's it. And should I tell you the formula for period of vibration of a liquid? This is even the formula set. So you can even use dimension to derive a formula in physics. So that's the expression for the period of vibration. Do we get that? Who doesn't understand? Just apply, just put ABC, then put the dimension, compare the two sides, do your indices. Many people are sleeping. 1, 2, 3, 4, 5, 6. Minority are sleeping. So let's continue then. Do we get that? Those who are watching online? I hope it's clear. I'll be at it soon. Do we have any past question from dimension there? You have one, Abi?
But it's all those words.
Yeah. We need them too. Like very much. Those words, we need them. Now let's write this so I can clean the board. Are we done? Where dictates that question?
Which of the following statements is or are false?
Which is or are false? Statement 1.
All base quantities in mechanics are about 2 in number.
All this.
All base.
Okay, all base.
Base quantities in mechanics are about 2 in number.
The first one.
Statement 2. A measured quantity without
mechanics are
about 2.
About 2 in numbers. Statement 2.
A measured quantity without unit has incomplete meaning.
A measured quantity
without unit has incomplete meaning.
Without unit
has incomplete meaning.
Incomplete meaning.
All physical happenings are physical quantities.
All physical happenings. This is your test question. Happening are
physical quantities.
Physical quantity.
A quantity that has no dimension but has its unit as a supplementary quantity.
That has no dimension
but as units is known as a supplementary quantity.
But as unit
is known as supplementary quantity.
Is known as supplementary. So which one is false? A is false, right? Let's delete that guy first. So these are part of a measured quantity without unit. Sorry. A is all base quantity in mechanics are about 2 in number. No. What's the meaning of base? Fundamental. We have about 8, 7 or 8 fundamental. So this is wrong. A measured quantity without unit has incomplete meaning. True or false?
A measured quantity is true.
A measured quantity without unit has incomplete meaning. It's true. It's not most true. If there is no unit, no, then we used to say, what do we used to say there? Then we used to say the quantity without unit is meaningless. It's not meaningless, just that it's incomplete. Are we together? It's not meaningless. We also, a quantity without unit are also called pure numbers. You should take note of that. Pure numbers. The quantity without unit, they are also called pure numbers. So pure numbers are not unit, they are not meaningless rather, just that they are incomplete. Take note of that. So a measured quantity without unit has incomplete meaning is true. The meaning is not meaningless, but the meaning is incomplete. So this is true. This is false. This is true. All physical happening are physical quantity. Yes or no?
All
physical happening are physical quantity. True or false? Let me check the last one. The quantity that has no dimension but has unit is
But by saying mechanical.
sure physical happening. And things that are happening that you can see now. All physical happening are physical quantity. True or false? We are coming back to that. I don't measure with my palm. A quantity that has no dimension but has unit is known as supplementary quantity. First of all, what's the meaning of supplementary? What's the meaning of supplementary?
Like additional.
A quantity that has no dimension but has unit is known as supplementary quantity. Even before knowing supplementary, this is false now. But what's the meaning of supplementary? Like adding things together.
Like additional.
So a quantity that has no dimension but has unit is like an additional quantity.
Like extra. It's not possible.
Yeah, that's false actually, obviously. Now let's check 3 back. All physical happening are physical quantities. This is true. Okay, go and check. It's true. It's true, I think. What number is that? What number of question is that? Now that should be 1 and 4. But what number of question is that?
Sir,
Like,
how is that? Number
False.
is false.
It's false now.
the
one that has no
options
dimension,
the options that I read said statement 2 only, 1 and 2 only, 1, 2 and 4 only, 2 and 4 only, 2, 3 and 4 only.
How many options are there?
Come back. Is there one only there?
Sir, according to this page, they say the supplemental quantities are fully unit for no dimensions.
It's known as supplementary. Me, I was saying it's known as it's supplementary. Okay. This is true. Is there one only the option? That's what I'm asking.
No.
There's no one only. Read the options again. Read the question
2
again.
only, 1 and 2 only, 1, 2 and 4, 2 and 4 only, 2, 3 and 4 only.
This one is true, Abi. The question again. A major quantity without
The
you.
answer is 1 and 2.
No, this is true. I've seen this in past question before. Now it's true. Even the man said it. Now a quantity. It's true. It cannot be false. 2 cannot be false. Is there 1 and 3 there?
We have 2 only, 1 and 2 only.
What number?
One,
What
two,
number?
and
Actually,
four.
that's your test.
No.
Okay, it's not your test.
It's not safe.
Oh, shit, and I'm just disturbing myself. I thought it's your test now. That's why I want to confirm. Like, where did you see it?
It's like it's tutorial question.
I hope it's not my own tutorial question. 2 is correct. I've seen it in past questions before. 2 cannot be false. A major quantity without unit has incomplete meaning. It's true. It has incomplete meaning. That's true. It's even the man said it. The man, Professor Awe. Not that it's meaningless.
The question is not correct.
Yeah. So 2 is correct. It should be 1 only.
The question is not correct.
Should be 1 only. So 1 only is false. So please, this guy is true. 2 is true. I hope that's clear now. 2 is not false. The major quantity without unit is not meaningless. Just that the meaning is not complete. It still has some meaning. Yeah. Also take note of this. Supplementary quantity, a quantity with unit but without dimension. Oh yeah, do we have another question there? Like words like this.
Okay.
Wait, did you see
So it's been confirmed back.
Yes.
The question that I have is okay, all right. The next question.
No, there's no one.
The next question.
Which of the following statements is or are correct?
Statement A.
The ratio of distance to displacement is always 1 for a body moving with uniform speed. The ratio of distance to
Let's examine it one by one as he's saying it.
the ratio of distance to displacement is always 1 for a body moving with uniform speed.
The ratio of distance to displacement is always 1 for a body moving with uniform speed. Is that true? Now, first of all, what is uniform speed?
Speed that is not changing.
Is uniform speed always about straight line?
No,
I'm coming.
it's different.
Yeah, we can have Uniform. I think uniform is the same thing as constant now.
Yes.
So we can have uniform speed in a circular motion now, where speed is constant but velocity alone changes. So since uniform speed is not only attached to straight line motion, the ratio of distance and displacement is not always 1. Assuming it's only a straight line, then distance equals to displacement. For a straight line motion, distance is same thing as displacement. Their ratio will be 1. Since we can also read the question again.
The ratio of distance to displacement is always
1. It's not always. Because in circular motion, it's not 1. Because we can have uniform speed in circular motion. So that one is false. Question 2.
Current is a fundamental.
Even there is a topic in that in your slide, uniform circular motion, where we talk about uniform speed. So since we have uniform speed in circular motion, displacement is not equal to distance. So it's not always, but at times it can be due to straight line motion. So question B.
Current is a fundamental quantity while charge is a derived quantity, not because charge as a quantity depends on current.
Actually, I think charge depends on. Well, the first part is correct.
Yes.
Current is fundamental, charge is derived. Continue that.
Not because charge as a quantity depends on current.
Charge actually depends on current. Yeah, because a current need to pass through a circle before you can store a charge. Are we together? So charge depends on current actually. And we also have Q equals IT. Are we together? This is the fundamental uniform for.
But it's still correct.
It's correct.
But the thing is saying not because.
Okay, wait though.
He said current is a fundamental quantity while charge is a derived quantity, not because charge as a quantity depends on current.
Okay, I get.
It's correct.
It's true. The thing is that not that this guy doesn't depend on current, though. It depends. But that's not the only reason why it's a derived quantity. We can derive charge without current. Let me get a formula that can combine charge together. We have Q equals to, is it CV?
Yes.
Do you remember?
Yes.
Here now there is no current, they only have capacitor and voltage. So we can derive charge using capacitor and voltage alone. Do we get what you are saying? So not because it's actually a derived quantity, not because it depends on current actually. That's true. So that's also true. What's the next one?
Human body can never act as an accelerometer as a speedometer.
Human body can
never act as an
accelerometer. That is what we use to measure acceleration, but as a speedometer. Human body. Let's check. Call the next statement first before we reason down.
Then the next one. A body may be accelerated even when it is moving uniformly. A body may be accelerated even when it is
No, that's false. That one is false. Uniform motion, there's no acceleration. That's false. So 1 and 2, let's check that 3 very well. Human body, call that number 3. 1 and 2 are true now. Now let's check if 3 is also true or false. Read that number 3 very well.
Human body can never act as an accelerometer.
Which means they are saying we cannot use human body to measure acceleration. But
as a speedometer.
Is that not false? I'm coming. And human body measure, if human body can measure speed, to be able to measure acceleration. Come here. It's false.
That means 2 and 3. Yes, it's correct. 2 and 3.
What did they say before?
2 and 4. 2 and 4.
Really, what was the question before?
Which of the following statements are correct? It's only 2 and 4.
Sir, how do you use the body to measure auto? Because like distance respect to time.
time taking. So and for the body to move from one speed position to another.
Is one of I thought one is correct.
No, one is one that talked about for a body moving with uniform.
Okay, one is not correct.
But two is currently fundamental quantity.
Okay, two is correct. Okay, you are saying something.
Yeah. They said human body can be used as a speedometer. Since distance with respect to time is speed, right?
Yeah.
Yeah. So can the human body be regarded as all
He said acceleration is very
I work human body. I work like
to measure acceleration. But I use human body to measure speed.
So and I already the time I need to go that
That would be distance.
and
that's
speed.
Exactly.
Yeah, we agree that it can measure speed. Let's check for acceleration.
Can't be acceleration.
Oh yeah, why? Let's verify it.
Firstly, I think because it's based on the direction of what's called the direction of
According to the options here, it's like the two that we pick to be correct. That's the reason I get.
Me, I have not picked you, but let's hear.
Like the second one, we talked about current as a fundamental quantity, and the last one that a body may be accelerated even.
No, that
one is false.
That one that is true. They didn't say anything about it. That question 3, statement 3. That's accelerometer, be speedometer, be kilometer.
That statement 3.
Okay. It's actually true, but I'm still looking for a way to.
2 and 3 only.
Yeah, 3 is true. 2 is also true. But I'm looking for a way to get that acceleration stuff very well.
It's wrong.
because no, we can still use body to calculate acceleration.
Okay.
How can we use that one?
Do you have another question? Please, good question, I beg. Do you have a question?
Actually, for
P is actually interesting. What do you say?
like UI practice.
Yeah.
Even the one that is like we have done it. Have you seen it?
Yeah, you are a past question.
Which of the following statements is true?
About what?
The first one, all quantities in mechanics are derived from the combination of 3 or 4.
The 3 or 4?
Yes.
I know, wrong. It's only derived from 2 solid x or 2.
All quantities in mechanics are derived from the combination of 3 or 4 fundamental quantities.
It's wrong because it's 3, not or 4. Or 4 is not there. It's just 3 mass length and time. So it's wrong.
The answer of this statement is true. The second one is dimensionless physical quantities do not have units.
It's wrong because you have some quantity that have unit but they don't have dimension, like radian. All those degrees, their units are measured in degree but they don't have dimension. So 2 is also wrong.
The third one, the dimension of a physical quantity is the same as unit of measurement.
That's also wrong.
The fourth one, the
dimension is not same as unit, so that's wrong.
Fourth one, regardless of the unit used for a physical quantity, the dimension of the physical quantity will not change.
Yeah, regardless of the unit, since the unit is valid, the dimension doesn't change. For instance, acceleration is meter per second square. Acceleration is also Newton per kg. I hope we know. So whether we use this unit or this unit, the dimension still remains the same. Sorry, per second square rather. So either of these units for acceleration, the dimension still remains the same. 4 only. Is that the answer?
Yes, sir.
All right. Another one.
Which of the following statements is or are correct?
Statement one.
A dimensionally correct equation may be physically correct.
So you have question, really? I mean, I know you have question. If I hear it, I know you have question. I know proper question. If I go see it. Is that your question? You're just sorry now. Oh yeah, let's have it, Sha. Let's just have it.
A dimensionally correct equation may be physically correct.
A dimensionally correct equation. The way the question is like just thinking like a dimensionally correct
Equation may be physically correct.
That may is conditional because if it's dimensionally correct, it will surely be physically correct. Or even dimension is used to verify equations. Like since we are referring to equation, like all those equations, Newton and everything. In fact, for us to know that an equation is correct, we use dimension to verify it. So if dimension has verified that it's correct, then there should not be condition again that may. It surely be correct. So that's like false. So it's not may, it shouldn't be conditional. Another one.
Statement 2. The dimension of a derived quantity is never zero in any base quantity.
Dimension is never zero. Even dimensionless quantity doesn't have dimension of zero. They have dimension of 1.
So that's false.
It's false.
A base quantity cannot be represented dimensionally in terms of the rest of the base quantities.
Wait, I get that question. A base, like a fundamental quantity, cannot be represented dimensionally. That's true.
Yes.
I can't represent mass as length. Do we get? A fundamental quantity cannot be represented dimensionally in terms of the rest of the fundamental quantity. That's true. So that's true.
The dimension of the base quantity is zero in any other way. The dimension of the base quantity is zero in any other base quantity.
The dimension?
The dimension of a base quantity is zero in any other base quantity.
Yeah, that's true. 3 and 4. But let me check that for very well. The dimension of the base quantity. No, it's false. Dimension cannot be zero. It can be 1. So the answer is 3 only.
And there's another last one.
Okay, yeah, I'm done.
A physical quantity without units has no meaning.
No, it's false. It should be incomplete meaning. So 3 only. Is that what that is there? Which one is correct?
The first option said 1, 2, and 3. 1, 3, and 4. 2, 3, and 4. 1, 2, 3, and 4. Then 3 and 5.
Okay. What's that 5 again?
A physical quantity without units has no meaning.
The answer is 3 only. 5 is wrong. Is there anyone attached to 3 again? 3 and what again that is there?
1, 2, and 3.
1 and 2, it's obviously. Kilo and 1.
A dimensionally correct equation will be physically correct.
Okay, let's just assume may correct. What's 2?
The dimension of a derived quantity is never zero in any base quantity.
Yeah, it's true now. We said it's true then. That means 3 is also correct.
Yes.
What of 3?
3. A base quantity cannot be represented.
3 is also correct. So that means that may number 1, they count it as correct then. So 1, 2, and 3. But I just like that may should not be because it's conditional. If you use dimension to verify an equation, automatically the equation should be correct.
Also, this guy question I asked that quantities in metrics are based on 3
Yeah.
or 4.
No, it's 3. According to the slide.
And he says I understand, but all looks conditional in that situation.
Like when they say 3 or 4, like we should have said that is correct.
Like 3 or 4. That means it will be 3 or it will be 4.
And we already said that statement is wrong. But it's just 3. It's not conditional. Like it's specific. is 3. So it's not it can never be 4. It's just 3. Even the way your slide put it is that, let me say our slide, okay, your slide, not our slide. The way your slide put it is that all physical quantity under mechanics, like all under mechanics, mass less than time, like they are dimensionally related to mass less than time, just the 3. In fact, they are in past question, just 3. In fact, they will also put 3 only, and still correct. What's time now? 2:52. That time it is bad. So let's move on, shall we? Somebody's home. Shall we? Let's do more on dimension. There is a question. There is a question in. Can I still remember this question?
There's a question.
No, the one I did in another level first test. I'm trying to. I think number 4. That one that is related to dimension. Why won't that they do me like this? Oh yeah, any question? Yeah, let's
Displacement of a particle in XY shape is given by x is equals to at squared plus b, and y is equal to dt cubed minus e.
Find dimension of A, B, and D.
ABD.
Eh?
ABD. No, okay. Where t is time from rest and ABD are constant. Okay, AB and D.
T is time, A, B, D, and constant. So let's find dimension of A, B, and D. Since X and Y are in meter, B is L and obviously. A square is also what? L. A equals to LT minus 2, abi? We've gotten A and so DTQ equals to L, abi? Y, L. So D equals what? LT minus 2. So the correct answer is LT minus 2, LT. The arrangement is important too. They ask you A, you are wrong. So you see some options they will be the same, but the arrangement will differ. So very important. Any other question? I'm thinking of entering vector very soon. Given that what? Given that E is equal to after given that E capital letter.
Yes. Equals to 2/2. Find the dimension of
E. Well, let's check this. So here we have E equals to root 2. Okay, now we have to remove the root first, right? By squaring both sides. So this becomes E squared equals to what? 2/t.
And 2 has dimension of 1. T has dimension of 1.
We are even asked to find the dimension of E.
That's T raised to minus 1. They will now remove the square.
T is
So that means we still do this. E equals to root 2 over root t. E equals to 1 over root t. Are we together? The root 2 has a dimension of 1. So that's E equals to what? 1 over t, 1 over 2 equals to t raised power minus 1 over 2. Is that the answer? No option.
like it's not solved yet.
Or this is the answer. I'm just trying to confirm something. And we have 1. This is the answer. Don't if you square both sides, you still return the square back because you are looking for E, not E squared. So you still have to return it back. So this is what you get. T raised power minus half.
You can even consider the two again. Just one.
Yeah, actually. Just to be mathematically valid as well. Dimension violates some law in maths rather. Should we enter vector?
Yes.
Let's go again for this guy.
I'm thinking of dimension. Was something. Alaja, what's your Then we'll go and let you see. Hello, are we there? Ilé tó ṣe wá yóò ń para active. Are we there? You wey just come dey shout active. But this guy don dey since o, this yaya boy. Ó lè jẹ́ ọmọ MBPS báyìí, àwọn ló máa ń kàwé. Àkàyàsó. I think there are six of them. Part of that, I want to do this dimension very well because people are not much today. I'm trying to remember if there are some facts. Yeah, let me give you something like this. If y equals to a sine wt minus kt, where k is a constant, is it kt or kx? Wt minus kx are that progressive wave function formula. Yeah, Wt minus kx. 2πft, yeah. Wt minus kx. Y equals a sine Wt minus kx. Find the dimension of
direction of space.
okay, if W is I like the question. If y equals a sine Wt minus kx, if W it's not possible, I just want to say it. If W is in kg, no, it's not kg actually. If W is in kg, what is the dimension for k? What is the dimension for k?
If W
is in kg, what is the dimension for k? And the dimension for A? A and K, what is the dimension?
That and y is what?
Where y is in meters?
Y is what?
What is the dimension for A and K? Where W is in kg and y is in meters? T, x that's displacement already. X and y they are in meters. T is in time.
Wait, W is in kg.
Yeah.
What are we?
K and A. W kg, y in meter, x in meter, T is time.
A is meters.
What do you get?
A is in L,
Yes.
What of
Why
A?
K is ml minus 1t.
Are you sure?
Àwọn bọ̀bọ̀ yìí ṣáná, àwọn màmá yìí ṣáná. Kí lẹ pé ké o? Màmá kí lẹ pé ké? Bàbá kí lẹ pé ké?
ml minus 1.
ml minus 1. Whenever you have, whatever you have inside a trigonometric function, whatever you have, no matter how huge it is or how small, the dimension is always equal to what? 1. So all these guys, they are inside trig function sign, whether tan or cosine, whatever you have inside trig function has a dimension of 1. And together with the trig function, also have dimension of 1. Sine, everything here has dimension of 1. And everything they also has dimension of 1. The inside of trig function equals to 1 as far as dimension is concerned. And together with the trig itself has dimension of 1. So here you can say WT equals to what? Kx, right?
Yes.
So W, since W is in kg, MT equals to what? KL, abi? K equals to what? ML minus 1 what? T. Look over here. So this is correct. Are we together?
Yes.
What of A? A is
Yes.
L. So here we have y equals to A times 1, abi? That means y equals to A. And that's what? You don't really, whatever is here, whether it's even trig or not trig, since it's multiplying A, that means everything is just okay, you can't conclude like that. A is L because everything here is 1. If everything here is not 1, you can't conclude that A is L. So we have, so y equals to A, then since y is in meter, A also is what? It's in meter. You know why you can't conclude that A is also L? Assuming here we don't have, here we just have WT minus KX. You can't say A is L. Though it's everything here that is equal to L. Everything together. Since they are equal to, so everything is equal to L. So it could be that A here is some maybe T minus 2. Where all this one together is LT squared. Do you get? So you can't just conclude that A is L. You can only say A is L because of the trig that we have. Because everything here becomes 1. So A times 1. I hope it's clear. So that's that for that. So let's move to vector. Oh, we are tired. Vector analysis. Help us to open the slide. Let's first do that first question here.
So is it the school slide?
Yeah. Page 102. And 102 lower lower slide there. No, it's 102 before they turn it to 101. A lady there before you guys resume. She did not attend my Telegram class. She was like, whenever I said okay, it is time. Tí mo wá send the slide, tó wá ṣí slide, ó wá rí pé 102 ló wà lórí rẹ̀. Àgbáyé kò wá attend class mọ́. Ni ó wá dọ̀yọ̀ kan. I'm not there this time, like I send it through broadcast. No worry. No, but I'm not busy in class. I said I'm not doing the course. Maybe it's 101 no, lọ́mọ pharmacy. Ṣé pharmacy ló ti wà? Is it pharmacy? I think it's pharmacy. O ṣe course wo yìí? Ó lóun ò ṣe. Máa ń jọ course. Ó ní fees 102. Ó lóun ṣí slide ẹ̀ pé 102 ló wà lórí ẹ̀. Ó ti lọ́lẹ̀. Yeah, let's continue. It's actually CC man that turned everything upside down. Are we? How many of us don't know that vector has both magnitude and direction? Can anything exist? Can anything exist without magnitude but direction only?
No.
Are you sure? What about a unit vector? Does a unit vector have magnitude or not?
Yeah.
What's the magnitude of a unit vector? 1 unit. So it has, so no quantity can exist without magnitude actually. Are we together? No quantity, even if it's just a dot. No quantity can exist without magnitude. That's why we only have scalar and vector. That you have magnitude only or you have both. You cannot just exist without magnitude. Okay, imagine I remember something that's inside phase 1. So let's leave that in second semester. Shall we? We are that first question there. A boy. Starting with a boy.
Two boys pull a
Okay,
dog
2 boys. Don't mind me.
with forces 10 Newton and 15 Newton.
F1 equals to 10 Newton. F2 equals to what?
15 Newton. Inclined at 60 degrees to each other.
Inclined at 60 degrees to each other.
Find their resultant in magnitude and direction.
Find their R in magnitude and direction. Using the parallelogram law of vector. 10 Newton, 15 Newton. They are inclined at 60 degrees to each other. So we have to find the resultant. Are we together? Remember the sine rule. R squared equals to A squared plus B squared minus 2AB plus what? Cos 180 minus theta. Are we together? But I prefer you always use this. R squared equals to A squared plus B squared plus 2AB cos theta. They are the same. Are we together? So you don't need to be stressing yourself with this. So cosine rule is the one that deals with it, but you don't need. Just use plus and use the theta given to you. So here now we have R squared equals to 10 squared plus 15 squared plus 2 times 10 times 15 cos 60. So we have 100 plus what? 225 plus 300 times 0.5. Abi?
Yes.
So we have 325 300 times 0.5. R square equals to, so R square equals to what? 475. R equals to root 475, and that's what? 21.8 Newton. That's 21.8 Newton. Now that's our magnitude. That's our magnitude of resultant. What of the direction? You can have 2 answers for your direction. Yes or yes?
Yes.
Consider your direction is in the 10 Newton force. Is to the 10 Newton force. Or to the what? 15 Newton force. Now let's divide this into 2. Let's call this theta 1 and let's call this what? No, theta 1 plus theta 2 is 60 degrees. Now let's find theta 1. Bringing out that triangle. Bermuda triangle. You know this 15 is equal to this place. Parallelogram. 2 sides are parallel. 15. So here we have. You know, if you find this place, you get what? 120. Have you?
Yes.
The opposite angle of a parallelogram, they are equal. This guy is also what? 120. Are we together? So now we need sine rule. This side have its angle theta 1, which you are looking for, and this angle also have its side 21.8. Are we together? No, our resultant is 21.8. We have angle 120 facing it. So how do we get it? 180 minus theta. No, our theta is 60 degrees, the original question. Do we get? An opposite angle of a parallelogram, they are equal. 120, 120, 60, 60. The total angle is still 60 degrees. 60 plus 60 plus 240 gets 260. So these are resultants. So let's say 21.8 divided by 120 equals to theta 1 is the angle facing this side. So we have 15 over what? Over what? Theta 1. Since I use angle at the bottom here, I use angle at the bottom here. Cross multiply. So here you have 21.8 theta 1 equals to what? 15. Sorry, sine. 21.8 sine theta 1 equals to what? 15 sine 120. So here we have sine theta 1 equals to what's sine 120?
That's sine 60.
There's negative there. Or just 0.866 over 21.8. What do we get? What do we get? 30. Should be 30, so it's too big. Now, if you get this guy, you don't need to be looking for theta 2 by using sine rule again. Just subtract it from 60. Since the total angle there is 60. Now, whatever we get here is the direction of the resultant to the 10 Newton force. Whatever you get as theta 2 is the direction of the resultant to the what? To the 15 Newton force. Do we get that? You get this? No, because you are using theta 1 is the direction of the resultant to the 10 Newton force. And you don't need to use sine rule to stress yourself, just subtract this from 60. So the total is 60. Whatever you get as a theta 2 is the direction of the resultant to the 15 Newton force. So either of the two can actually be your answer. The 10 Newton force, you have different value for the direction. The only time you can just divide that 60 by 2 is if those two forces are equal. I don't say theta 1 is 30, theta 2 is 30. If those two forces are equal. Are we together? There is should we continue? Should we continue? Elijah, should we continue? How many people want us to continue? How many people want us to continue? How many people want us to continue? Tech. How many people want us to continue? How many people? Sorry. How many people want us to stop? So you don't even know where you belong. That continues. So this will be you already sharp. We have got the next question. That question that will be resolving to horizontal and vertical. Let's do one of it. Even if you want to call it a day, let's do one. Okay.
If three forces,
Yeah, sharp.
if three forces F1, if three forces F1,
Let's pay attention to this.
is equal to 20 Newton, 30 degrees northeast. F2, 50 Newton along west. F3, 40 Newton, 50 degrees northwest.
Acting on the body.
Acts on the body. Find the resultant in magnitude
And direction. For our F1, 20 Newton northeast. Whenever you say northeast, it means the angle is coming from where? North. And northeast can also be said to be what? East of north. East of north is the same thing as northeast. North of east is the same thing as east north. South of west is the same thing as west south. West of south is the same thing as southwest. Are we together? So whether east of north or northeast, the angle is coming from what? North. So this force, when it gets to 30 degree, are we together? Yes. The force gets to this part, 30 degree, which is 19 Newton. So we need part of the force that is on the horizontal axis and part that is on vertical axis. Do we get what I did?
Yes.
So part of it that is Fx, horizontal, and Fy, vertical. Now this 20 Newton is our hypotenuse there, right?
Yes.
And our angle is 30 degree. So Fs we use sine because it's horizontal. There's no way about that. Fx here is facing the angle. We want to find Fx since it's facing the angle, it's opposite to the angle. So we are using so. Fy is adjacent to the angle, we are using car. Are we together? So sin theta equals to what? Opposite. What's our opposite? Fx, abi? Over hypotenuse, 20 Newton. Isn't it? Cross multiply. Fs equals to what? 20 sin what? 30. And the fact that it's on the horizontal axis, our Fx is horizontal. So that's I, abi? And it's positive. Now for our Fy, it's adjacent. Cos theta equals to what? Fy over 20. So Fy equals to what? 20 cos what? 30. It's on the y-axis, that's what? J. So our F1 equals to Fx rather. Sorry, our F1 rather equals to Fx plus Fy, which is 20 sin 30i plus what? 20 sin what? 20 cos what?
So
30j. Are we together?
Yes.
Now for F2, F equals to negative 50j. How do I know? Along west, not southwest, it is west, and that's negative F. I rather. Negative x axis, which is negative I axis. Are we together? Now for F3, F3 equals to Fx plus Fy. What's our Fx? We are told that F3 is 40 Newton 50 degree northwest. Northwest. 40 Newton 40. Yeah, are we together? Sorry, 40 Newton 50 degrees. Let me draw it very well. Are we together? 40 Newton 50 degree northwest. So it's coming from north, it's going to west, the angle. So when the angle reach here, these are 50 degrees. The 40 Newton is, your force is always the hypotenuse. So let's find our Fx. So sin 50 degree equals to opposite Fx over 40. If we cross multiply, we are going to have what? 40 sin 50 as our Fx. So we have 40 sin 50i. Is it negative or positive? Negative. So we have minus for here. What of our j? Our j will be what?
Positive.
40 cos what? 50j. So punch calculator, punch calculator, punch calculator. Yeah, let's punch. F1 equals sin 30 is 0.5. That's 10i, abi? Isn't it? Plus 10 root 3. 10 root 3j. Yeah, it's 10 root 3 because 30 is root 3 over 2. Root 3 over 2 times 20, that's 10 root 3. F2 F2 minus 50J F3. What is F3? What is minus 40 sine 50?
Minus 40 minus 30.64.
Alright. 40 cos 50 ńkọ́? 74 point something àbí?
40 plus
50.
25 points.
Woo! Okay, the addition now we have 74. 25 points what?
7 1.
J. Let's add all the I together. 10I plus minus 50I, that's minus 40I. Plus this,
Minus 70.64
our F total. Minus 70.64.
I.
What of the J? 10 root 3. What's 10 root 3? Let's deal with it. 10 times root 3, what do we have?
70.32.
Plus 25.71. 43 point what? 03. Let's find our F magnitude. Square root of minus 70.64 square plus what? This 43 minus 70.64I plus 43.03J. Now our F total is square root of minus 70.64 square plus what? 43.03 square. What do we have there? What do we have there?
6,000.
We have take the root. 80 something, abi?
$82.71.
Newton. That's the magnitude of our resultant. What of the direction? Use tan.
Tan inverse 43.
Theta equals to tan inverse of what?
43.
14.03. Don't bother about this minus 70.64. But you are going to use it to determine the quadrant. If you are not using quadrant, if quadrant is not in your answer, use the negative. To give you another answer, it will give you negative degree, which must be your answer. But if you have quadrant, you don't need to add it. Just use the coefficient alone, the magnitude alone rather. So we will be using the negative to get the quadrant. So this over this and take the tan inverse. What's our theta? 31.74 degree. Now let's check which quadrant.
34.
31.34 degree. Now let's check which quadrant. Our J, the addition of the total force, our J is positive, abi? J is positive. What's our X? Negative. That's where 31.34 degree on the second quadrant to what? To the negative x-axis. Second quadrant to the negative x-axis. What am I saying? Second quadrant to the x-axis. You don't need to put negative. The negative is y is on the second quadrant. To x-axis, just saying like to the horizontal axis. 31.34 degree on the second quadrant to the x-axis, to the horizontal axis. I hope it's clear. What's time now? So let's just call it off. So we do, trusting God, we do more when others will come tonight. So some are not around because of the COS. Go and prepare for your COS, I beg. Thanks. Hello guys, we are done. So alright, good night. I will upload the 2 videos so guys you can watch later. Alright, bye. Take care.